All right, so this has started recording, so just make sure that you are muted. All right, I want to take you through this question in particular on epicyclic gears. All right, the reason for that is because I noticed most of you struggled with the question on epicyclic gears. All right, so I'm going to give you guidelines as to how to approach such questions and trust that it will help in having to deal with questions based on epicyclic gears if it happens that you get a question on epicyclic gears in the final exam. Right, as far as simple and compound gears, you'd have to visit my videos once again if you need clarity there or if you need to recap on that. If there are questions, though, based on any and everything that we've covered so far, you can ask me in the group or you can ask me privately as well. I will help you. Right. Right. So let's read this question. The epicyclic gear system shown in figure 3 below consists of a ring gear, also known as the annulus. Right, so this here is the ring gear. Right, so a ring gear or annulus is the type of gear that has teeth ground onto it on the internal. What is this? On the internal. This is what I'm looking for. On the internal true circumference. Right, so gears either have teeth ground onto them on the external true circumference or internal true circumference. So annulus or ring gears in particular have gears cut into them or ground into them on the inside true circumference. All right. So that is how essentially you spot an annulus. Right. So the annulus has number of teeth named as TA. Right, so that's this one. Right, so the biggest gear in the epicyclic gear system. Uh, the number of teeth has been labeled or has been denoted as TA with 80 teeth. Right. And then a sun gear TS with 40 teeth and a planetary gear TP with 20 teeth. So essentially, we've been given the number of teeth of all the gears that appear on this typical epicyclic gear system. Right, so you get a typical epicyclic gear system where you have an annulus, you have planetary gear or planetary gears, and then you have the sun gear and obviously the arm. Right, and then of course you get also atypical cases where you just have um, say spur gears that are in mesh and are connected with an arm, right? But you don't necessarily have an annulus like you do in a typical epicyclic gear system, right? The concept you follow or the concept of epicyclic gears remains the same regardless of the case. So be it you're looking at a typical case or one that is atypical. Right? The guidelines that you follow in having to break down problems based on epicyclic gears remains the same. Right? So pay attention. Right. So that's the given information. You've been given all the number of teeth. Now, it is important to note that with epicyclic gear systems, we have to tabulate our information. Meaningly, on the table, you have two conditions. The two conditions we say are fixed conditions because they do not change. Meaningly, if you look at the first row of conditions here, it is to fix the arm and rotate the annulus by one revolution clockwise. So don't mind what is written here, right? I say gear A here because they've labeled the annulus as A, right? The typical first condition is to fix the arm and to rotate the annulus by one revolution clockwise. And then the second condition is to multiply the first condition by X and then you add Y. So these two conditions, conditions 1 and 2, are said to be fixed because they remain the same always. Right, the first condition will always be to fix the arm and rotate the annulus by 1 revolution clockwise. And the second condition will always be to multiply the first condition by x and then add y. Right, so in having to complete the first condition under each column, it is based on having fixed the arm and rotated the annulus by 1 revolution clockwise. So in completing this condition, the first condition, essentially you are answering this question. The question that how does us fixing the arm and rotating the annulus by 1 revolution clockwise influence the other components? So in this case, the other gears, right? How does that influence the rotational frequency of the other gears? So if the arm is fixed and the annulus has been rotated by 1 revolution clockwise, how does it influence the planetary gear as well as the sun gear as far as their rotational frequency as well as the direction of rotation, right? So that applies to all cases. So cases, typical cases like the one we're looking at, or a case where you have an epicyclic gear that is a compound gear train. So by compound gear train, remember the difference between a simple and compound gear train is that with a compound gear train or with a simple gear train, the gears in the system are all fitted with their own shaft. Whereas with a compound gear train, you find that some of the gears are fitted with the same shaft. So you get a case where you have a typical epicyclic gear system where essentially you have an annulus, you have a planetary gear, you have a sun gear, you have the arm. But you find that that epicyclic gear system in particular also happens to be a compound epicyclic gear system, meaningly you find that some of the gears, for the most part, it happens to be the planetary gear. Some of the gears are fitted with the same shaft. Right? All that means is that the gears that are fitted with the same shaft, so for instance, if it's the planetary gears that are fitted with the same shaft, or the gear that is fitted with the same shaft with another gear happens to be a planetary gear, all that means is that the planetary gear and the gear that it is fitted with the same shaft with, all the information you are going to gather under one column. Because remember that if gears are fitted with the same shaft, what does that tell us? It tells us that the two gears are going to rotate at the same rotational frequency as the shaft also rotates in the same direction. So it is unnecessary to have two columns to represent those two gears. Why? Because essentially they are rotating with the same rotational frequency as well as rotating in the same direction. Right? I hope that makes sense. Does that make sense? Say something.
Yes, it does.
All right. Now, before we complete the first and second condition, right, I want you to take note of how I've arranged my columns. Right? So column 1 is the number of condition. Second column is the condition itself. And then next, I have the components. First and second component is based on the first condition. Fixed arm, hence I have arm as my first column as far as the components, and then rotates the annulus by 1 revolution clockwise, hence that is the next component, or that is the next column. Now the columns that follow, I want you to take note of how, in what order I arrange the columns. So the arm here has been denoted as arm D, so we can write D here. The annulus has been denoted as A, so we can simply call this gear A. Now, take note of the next column and why I use this column for the gear I'm going to use it for. And the reason why I'm going to have the components I'm going to place here is based on which gear meshes with the annulus. Right? So I look at the gear that meshes with the annulus. The gear that meshes with the annulus is the planetary gear. So because of that relationship, I then have gear P here, which represents the planetary gear, which is labeled as P. Right? And then, of course, meshing with the planetary gear is the sun gear. Hence, that is the components I have next. Right? So the way I arrange my columns of components is based on the relationship that the current component has with the previous component. Right? If you look at this one, because remember these two, right, are first and second based on the condition. The ones that follow are based on the relationship that you're going to place on this column, the relationship that this one has with the previous one. Right? And then, of course, this one the same. What is the relationship that this one has with the previous one? Right? Or you can look at it vice versa. Right? So look at it going in that direction. Right? By looking at which gear meshes with this one. This meshes with the planetary gear, hence that's the gear that follows. And then this one is also meshes with the sun gear, hence that's the component that follows. Right? The reason for that order is because of the guidelines that I'm going to give you that you have to follow in having to complete the first condition. Right? The guidelines I'm going to give you only apply for completing the first condition. Right? Now let's complete the first condition. First, let's write down the rotational frequency of the arm and gear, and the annulus as per the first condition. Right? As per the first condition, you fix the arm. So if something is not moving, it means its rotational frequency is 0. That is where that 0 comes from. And then as per the first condition, we have to rotate the annulus, so gear A, by 1 revolution clockwise. Right? Shorthand notation for that is +1. Right? Rotate the annulus by 1 revolution clockwise. So the rotational frequency as well as the direction of rotation of the annulus as per the first condition is +1. Right? Those two done. Now, these are the guidelines that you have to follow in having to complete these two. Right? So from a general perspective, not just these two, but whenever you look at an exercise based on epicyclic gears, in order to complete the first condition, these are the guidelines that you have to follow. So take note. Now, first thing you have to ask yourself, right, this is the column we're dealing with. Right, this is the column we are dealing with. Right, take note of what I said is the reason why I arrange the components or the gears the way I do. Right. Now, in order to complete this condition for this component, so for the planetary gear, you have to follow these guidelines. Right. It's just 3 guidelines, very simple guidelines. Right. If you understand these guidelines, if you use these guidelines, you will never go wrong with epicyclic gears. Right. In whatever level, be it Meccano N5, Meccano N4 or N5. Right. So when you do epicyclic gears in Meccano N5, you're going to use the same guidelines. Right. Easy peasy. Now, these are the guidelines. Now, the first thing you do is you look at which component you are busy with. You are busy with the planetary gear. So the first thing you need to do is these are the guidelines. First thing you need to do is to establish the relationship between this gear, so the gear that you're dealing with, and the gear that it meshes with. Right. So remember, based on how you've arranged the gears, you already know that this meshes with this gear. Am I making sense here?
Yes, sir.
Right. So first guideline is to establish the relationship between the two gears in mesh, or this gear and the gear that it meshes with, right? So we've established, right, just based on how the gears are arranged, that the planetary gears mesh with the annulus. Right? As you can see, even on this schematic illustration, this here is the planetary gear. It is meshing with the annulus. Right? So that's the relationship between the two. The gears are in mesh, which means because they're in mesh, it means their circumferential velocities are the same. So meaningly, the circumferential velocity of the planetary gears is equal to the circumferential velocity of the annulus. Right? That's the relationship between these two. So when I say establish the relationship between the two gears, the gears are in mesh, which means their circumferential velocities are the same. Right? Now, what does that mean? Now, that means essentially that NA, not NA, it means NP times TP is equal to NA times TA. Right? Now, I do break this down in one of the videos that's on my YouTube channel. I did send that video to you. Right? So if you want to know how we arrived to this point, just go back to those videos. Right? For now, I'm gonna go straight from here to this part because this is the part that is important anyway. Right? So essentially, this is what I mean by establish the relation between the two gears. The circumferential velocity of gear P is equal to the circumferential velocity of the annulus gear. Right? So that's the first one. Establish relationship between the gears in mesh. The second guideline is to establish direction of rotation. Right? The second one is to establish direction of rotation. Right? So by that I mean we've already established that the annulus is rotating clockwise as per the first condition. Right? This one is rotating clockwise. So the annulus, which is this one, is rotating clockwise. And clockwise is positive. So mathematically, we represent clockwise as positive. So we are going to leave this as positive. Now, if this is rotating clockwise, remember, take into account that this is the annulus. It has teeth ground onto it on the inside true circumference. Right? And whenever a gear meshes with the annulus, they tend to go in the same direction, which means if the annulus is rotating clockwise, the gear that it is meshing with, which is the planetary gear, is rotating clockwise as well. Right? Remember that we get essentially, in terms of direction of rotation, we get two cases. You get gears that have teeth ground onto them on the outside true circumference. Right? When those gears come into mesh, so if you have two gears, right? If you have two gears, right? If you have two gears and they are meshing with the outside true circumference, right? Meaning that these two gears have teeth ground onto them on the outside true circumference. These gears rotate in opposite directions, right? Whereas if you have one gear with teeth ground onto them on the inside true circumference, meshing with a gear that has teeth ground onto it on the inside true circumference, then these gears or this system of gears tend to rotate in the same direction, right? So that is just something to take note of, right? So here, as established, that when the gear that meshes with the annulus goes in the same direction or rotates in the same direction as the annulus, it means seeing that the annulus is rotating clockwise, it means the planetary gear is also rotating clockwise. So both remain positive. Now remember, this is the second guideline. The first one was to establish the relationship between the two gears. The second one is to establish direction of rotation, which we just have. Right? Both are positive because both are rotating clockwise. Third guideline is to solve for what you're looking for. Right? What are we looking for? We are looking for the rotational frequency of gear P. Right? That is denoted as NP. So we're looking for a rotational frequency of P, right, when the arm is fixed and the annulus has been rotated by one direction clockwise. So in order to do that, you must make NP the subject of the formula, which means you divide both sides by TP. So that goes, hence NP is essentially equal to NA times TA divided by TP. So that is what NP is equal to. All right, so just to complete this maybe, NP is equal to this. So NP, which is what you're looking for, is equal to NA times TA over TP. Now, what is NA equal to? What? NA is equal to positive 1. So essentially, you have positive 1 here times TA. Right? The number of teeth are all given. They said, I forgot to do this part. So TA is equal to 80 number of teeth. TP is equal to 20 teeth. Right? And then TS is given as 40 number of teeth. Right? So in having to substitute here, TA is equal to 80. So that's 80 divided by TP, and TP is 20. Now, what is 80 divided by 20? Quickly. That's straightforward. What's 80 divided by 20?
It's 4.
It's 4, which means NP, when the arm is fixed and the annulus has been rotated by one direction clockwise, the rotational frequency of the planetary gear is 4, positive 4 revs per minute. All right. Any questions on the 3 guidelines that you use in having to complete the first condition? Any questions? Right, no questions. Now let's do the same thing in having to complete the first condition for the sun gear. All right, so remember, the first thing you do is you establish the relationship between the current gear you're looking at and the gear it meshes with. So it meshes with gear P. The relationship there is that Vs, which is the circumferential velocity of the sun gear, is equal to the circumferential velocity of the planetary gear, which means Ns times Ts is equal to Np times Tp. Right? This is the relationship that has been established between the two. Right? So first guideline, right, is done. Second guideline, you establish direction of rotation. Now, the planetary gear, right, which is this one, and the sun gear, right, they are rotating or they are meshing, right, with the outside true circumference. So both gears have teeth ground onto them on the outside true circumference, which means that when they rotate, they're going to rotate in opposite directions. Which means, seeing that we've already established that the planetary gear is rotating clockwise, it means this we are going to leave as positive. If this is rotating clockwise, this is rotating anti-clockwise. So now you insert a negative sign there to show that this one is rotating anti-clockwise. Right? At this point, you've established the relationship between the two gears, and now you've also established direction of rotation. Right? Next, third guideline.
Sorry, sir.
Yes.
I might have missed the establishing of clockwise direction for the NP and TP. Can you just go back to that step?
Remember, that was covered when we looked at how to, or the rotational frequency of the planetary gear. Remember that because the planetary gear is meshing with the annulus. Right? Remember, I said to you that there are two cases of direction of rotation. One where if the gears in mesh have both have teeth ground onto them on the outside true circumference, those gears tend to rotate in opposite directions. But if one of the gears is a ring gear or annulus, meaningly it has teeth ground onto it on the inside true circumference, whichever gear that it meshes with will tend to rotate in the same direction. So meaningly, if the annulus is rotating clockwise, whichever gear that it meshes with, it is going to rotate in a clockwise direction as well. Right. So meaningly, because this is rotating clockwise, it means the planetary gear are also rotating clockwise. Right. That is how we established that NP, which is the rotational frequency of the planetary gear, is clockwise. Are we clear?
Okay.
Right. Now, when having to establish the rotational frequency of gear S as well as direction of rotation, now we are looking at the sun gear meshing with the planetary gear. Right, the planetary gear is now meshing, or we're looking at the relationship between the planetary gear and the sun gear. And when you look at both gears, right, even if you look at it from a schematic perspective, if you look at this schematic illustration of this epicyclic gear system, right, you can see clearly that the planetary gear has teeth ground onto it on the outside. The sun gear also has teeth ground onto it on the outside. And like I said, if those kind of gears come into mesh, they rotate in opposite directions. So having established that this one is rotating clockwise, it means since it meshes with this one, both having teeth ground onto them on the outside true circumference means that it is rotating anti-clockwise. Are we clear there?
Very clear, sir. Thank
So,
you.
United, just a quick question. How did you identify that NPTP is rotating clockwise? Thanks.
That's the question I just answered just now. The lady before you was asking the very same question. And the answer is, look at this schematic illustration. This here represents the planetary gear. Do you see that the planetary gear is meshing with the annulus? Do you see that?
Yes.
Right. Whichever gear that meshes with the annulus rotates in the same direction as the annulus. Now, the annulus, as per the first condition, is rotating in which direction? Hello. The annulus, as per the first condition, is rotating in which direction? Clockwise or anti-clockwise? I'm speaking directly to that gentleman. I will ask the question.
Positive means clockwise, right?
Okay, so I want that gentleman who ask the question to answer this one.
Yeah, it's clockwise.
Oh, okay.
Clockwise.
Right. If the annulus is rotating clockwise, as you've just said, having established that whichever gear meshes with the annulus is going to go or is going to rotate in the same direction as the annulus. So bearing that in mind, if the annulus is rotating clockwise, then how is the planetary gear, which is the one that is meshing with the annulus, how is it rotating?
Anti.
Okay, I'm going to say this again. Whichever gear that meshes with the annulus rotates in the same direction as the annulus, which means if the annulus, as you said, is rotating clockwise as per the first condition, then what does that imply for the planetary gear or the rotation thereof. Is the planetary gear going to rotate in the same direction as the annulus, or is it going to rotate in the opposite direction? Knowing what you know about gears that mesh with the annulus in terms of direction. Hello?
It will be in the opposite direction.
Okay, maybe someone else must explain this. Maybe I'm losing you guys somewhere. I'm sure someone understands what I just said. Can you perhaps?
Okay, I don't know if I'm explaining it right, but the example that you made earlier was that, especially the measuring part, since it's inside the circle and is touching the circle from the inside, that means it goes to the same direction because of that. But if it was outside next door, touching each other, then the directions were going to be positive. We're going to be opposing each other.
Okay, that is perfect. So,
oh, got it. Thanks.
The simplest way, right? The simplest way of understanding this is that whichever gear that meshes with the annulus goes or rotates in the same direction as the annulus. You already know that the annulus is rotating clockwise as per the first condition, right? This we've already established. It's given. It's fixed that as per the first condition, the annulus is rotating clockwise. That doesn't change. It remains the same regardless of the type of exercise we're looking at. As long as the exercise is based on epicyclic gears, the first condition will always be fixed, annulus rotates by one direction clockwise. Now, whichever gear that meshes with the annulus rotates in the same direction as the annulus. Which gear meshes with the annulus here? It is the planetary gear. Here's the planetary gear. So if whichever gear that meshes with the annulus rotates in the same direction as the annulus, what does that imply regarding the direction of rotation of the planetary gear? Is it clockwise or is it anti-clockwise? Hello? Hello? Did you guys go away or what's going on?
We're still here, sir.
Right. So, Mike, I asked you a question. Right. That bearing in mind that whichever gear that measures the annulus, right, whichever gear that measures the annulus rotates in the same direction as the annulus, it means seeing that the annulus is rotating clockwise, it means the planetary gear that measures the annulus is also rotating clockwise. That is how clockwise was established here. Are we clear?
Yes, sir.
Right. And then now, remember we're looking at having to establish the direction. Yes.
I think maybe okay, maybe it's confused because of the alphabet. I don't know.
The alphabet. Which alphabet now?
Gear P. Okay, let me explain to him if he still don't understand. I still hear Puti.
He must say something if he doesn't understand.
I still hear.
No,
Hello.
I'm sorted.
Oh, he's sorted.
Okay.
We go. All right, wonderful. Now remember, we are here now looking at the rotational frequency of the sun gear if the arm is fixed and the annulus has been rotated by one revolution clockwise. All right, so remember that you first establish the relationship between gear S and the gear that it meshes with, which is the planetary gear. That's, or this here is that relationship. And then second, you establish direction of rotation. At this point, we already know the direction of rotation of the planetary gear. It is clockwise, hence we leave it as positive. And then, as you see here, the planetary gear is meshing with the sun gear, right? And both have teeth ground onto them on the outside true circumference, which means they rotate in opposite directions. Bearing that in mind, it means seeing that the planetary gear is rotating clockwise, it means the sun gear is rotating anti-clockwise. That is why in having to establish direction, you then insert a negative for the sun gear, right? And then third one is to solve for what you're looking for. We are looking for NS, right? So we solve for NS by making it the subject of the formula. So you divide by negative TS both sides. So that cancels, therefore NS is equal to NP times TP divided by negative TS, right? So NS is equal to NP. Now bear in mind, you've already calculated NP and you got positive 4. So this will be positive 4 times TP. TP is 20, number of teeth, divided by negative TS. TS is 40. And what is this equal to?
-2.
-2. Right. So when the arm is fixed and the annulus is rotated by one direction clockwise, for this case, the planetary gear rotates at 4 revs per minute clockwise, and the sun gear rotates at 2 revs per minute anti-clockwise. Any questions? That is how you complete the first condition. That's the easiest way of completing the first condition. Right now, once you understand epicyclic gears, right, you obviously won't have to take this approach exactly as it is, right? But because it is still confusing you, this is the best approach to take in having to complete the first condition. The first condition is the most important condition for epicyclic gears. If you mess up this condition, it's pretty much over. And as you can see here, the question is 15 marks. It's normally 15 marks. But gear drives in the exam carry 15% or contribute 15% to the final exam. Right? So essentially what I mean by that is that if you mess up the first condition, it is pretty much over. 0. You get a 0 here. Right? That is why I broke this down the way I did, for you to understand exactly how to complete the first condition. Because every other condition after the first one is contingent on you getting the first one correctly. Are we clear here? Hello?
Yes.
We're clear, sir.
All right. First condition is complete. Now you complete the other conditions. So first you complete the second condition. Second condition is you multiply the first condition by x, and then you add y. So x times 0 is equal to 0. Then you add y. So that means that's equal to y. So x times 1 is x. Then you add y. X times 4 is 4x. Then you add y. X times -2 is -2x. Then you add y. Second condition complete. Right. Now, every other condition that follows after the second one will be based on either what's on the statement or the questions based on this exercise. Right. Now, we already know what's on the statement. So let us look at 2.1 and 2.2. Right. So 2.1, they say determine the speed and direction of the sun gear if the annulus is fixed and the arm D rotates at 60 revs per minute clockwise. Now, it is important to note that every condition that follows after the second condition is going to require 3 quantities. Right? So to complete any and all conditions that follow after the second condition, you need 3 quantities. Right? So you need what you are looking for. Right? You need what you are looking for, and then you need 2 other assumptions. The 2 other assumptions will either be given in the question itself, or they will be given in the statement. In this case, the 2 other conditions, the 2 other assumptions are given in the question itself. So meaningly, to identify what it is that you are looking for, they say here, determine the speed and direction of the sun gear. So essentially, we know that we are looking for NS. This is what we're looking for. All right, so remember I said to complete any other condition that comes after the second condition, you need 3 quantities, what you're looking for and 2 other assumptions. All right, so we've already established what we're looking for. We're looking for the rotational frequency and direction of rotation of the sun gear. 2 assumptions. If the annulus is fixed, so NA is 0. Annulus is fixed, so NA is 0. And then the other assumptions, and the arm D, so the arm rotates at 60 revs per minute clockwise. So the arm D, so we can call this ND, is equal to positive 60. All right. And that's all the 3 quantities that we need to complete the third condition. So third condition is arm D. So the column for the arm is this one is positive 60. And then the annulus is fixed. So this is 0. And then there's nothing on a gear P. We are looking for NS. So here you write, that is what we're looking for. All right. Then we say here 2.1. Right, 2.1 represents the third condition, which is now complete. We know this is what we're looking for, and we know these are the 2 assumptions that go with it. So now to be able to determine what we're looking for, this is what you do. Right, what you do now is you have to establish equations that you are going to solve simultaneously in having to determine what we are looking for. In this case, the rotational frequency and direction of rotation of the sun gear. And the way you establish those equations that you're going to solve simultaneously is you simply equate the second condition with the current condition. So the current condition is the third condition. So essentially what I mean is you have to equate this condition, so second condition, with the third condition. Meaningly, right, equating 2 and 3, it means y is equal to positive 60. This you can take as your first equation. And then you also have something here. So you equate this second condition with this third condition. So x plus y is equal to 0. So x plus y is equal to 0. That you take as your second equation. Now you equate this second condition with this third condition, which is negative 2x plus y. So negative 2x plus y is equal to NS, that you take as your third equation. Right? So all equations have been established. Now you have to solve them simultaneously in having to determine the rotational frequency and direction of rotation of the sun gear. Right? From here, or at this point, essentially Meccano is done. Right? All you have to do now is maths. Right? Otherwise, Meccano at this point is finished. Right? Now you just have to do math by solving this simultaneously. Right? Now, the best way to go about it is you look at NS, or the equation that has NS. right, which is the third equation here. Right, in order to get ns, you must have the value of y as well as the value of x. Right, now at this point, based on our equations, we do have the value of y, right, but we do not yet have the value of x. So you simply find the value of x, right, by using what? By using the second condition. I mean, not second condition, second equation. Right, using the second equation, we have the value of y. So once we substitute the value of y here, essentially x will be the only unknown. So you'll have the value of x. Right. So from the second equation, right, x plus y is 60 is equal to 0. Right. Therefore, meaning x, you transpose the 60 is equal to negative 60. Right. At this point, you have the value of y as well as the value of x, which means you can get or you can determine ns. So using the third equation, so ns is equal to negative 2x plus y. So negative 2, value of x is negative 60 plus y, which is positive 60. And what is this equal to?
$180.
So this is positive 180. So because it's positive, it means, so this is revs per minute. Because it's positive, it means this is rotating clockwise. So don't necessarily have to put it in brackets. You can just say clockwise. So you've established the rotational frequency as well as the direction of rotation. Any questions? No questions. Wonderful. Now let's look at 2.2.
Question. I
Yes.
have a question. So if it's the analysis is a negative, how will they ask the question, like if it's going anti-clockwise?
Then they will either say, see like how they did here, they will say the analysis is rotating at negative this, or they will give you the rotational frequency and tell you it is rotating anti-clockwise. There's many ways they can give that. They can either give you the same way that they did here with the arm, or they can
With
give
the sign.
you with the sign, or they can give you the rotational frequency and tell you that the gear is rotating clockwise or anti-clockwise.
Okay.
Right. Sometimes clockwise is indicated by writing this as positive. So meaningly, you find that maybe this has been written as positive, but there is no positive sign there. But the fact that there is no negative sign means that you take it as positive. Right. For some of these problems, you have to read between the lines. Are we clear?
Yes, sir.
Right. Any more questions?
All good.
No questions. Right. Let's look at 2.2. So because there are two questions based on question 2, that suggests that this question, right, will be our fourth condition. Right. So we just follow. Determine the speed and direction of the analysis. Remember I said every other condition after the second condition needs three quantities: what you are looking for and two other assumptions, which you will either get from the question itself or from the statement. So here they said determine the speed and direction of the analysis. So we already know what we're looking for. We are looking for NA. Now, two assumptions. If the sun gear is fixed, so the sun gear, that's NS. Sun gear is fixed, that means sun gear is 0. And the arm D rotates plus 30 revs per minute. So it's rotating at 30 revs per minute in a clockwise direction. So arm D, that is ND, is positive 30. Right? We have all the three quantities that we need to complete this fourth condition. Right? They said we're looking for NA. This is the column for NA. So that's what we're looking for. NS is 0, so that's 0, right? And then ND, the arm, is positive 30. Fourth condition is complete. Now, how do we determine NA? We determine NA by establishing equations that we're going to solve simultaneously to determine NA. And how do we do that? You simply equate the second condition with your current condition. Our current condition is condition 4, so we are going to equate the second condition with the fourth condition. So meaningly, y will be equal to 30. So y is equal to 30. You take that as the first equation. Now you equate the second condition, so x plus y, with the fourth condition, so x plus y is equal to NA. So x plus y is equal to NA. Take that as your second condition. And then now you equate this condition, negative 2x plus y, with the fourth condition is equal to 0. So negative 2x plus y is equal to 0. And this you take as your third equation. Once we've established the equations that we're going to use to solve simultaneously to determine NA. So now to determine NA, we establish what exactly do you need. You need the value of x and the value of y. Right. At this point, based on our equations, we have the value of y. Y is equal to 30. Right. But because we don't have the value of x, it means you have to first calculate the value of x. So that we can do using the third equation. But from the third equation, we know we have the value of y. Right. After having substituted the value of y, x will be the only unknown. Hence, you'll be able to calculate the value of x. Right. So from the third equation, we have negative 2x plus the value of y is positive 30. So 30 remains positive is equal to 0. Right. Now you transpose. See here, obviously you can be smart. You can either transpose the negative 30, which you don't have, to y, because the coefficient of x is negative. So it's better to just transpose this term so that it becomes positive on that side. So doing that, it means this becomes positive 2x is equal to 30, which remains positive. All right, so now you solve for x, divide both sides by 2, which means the value of x is equal to what? Is equal to 15. Right. Now you have the value of x as well as the value of y. So now you can get NA. So calculating NA from the second equation is x plus y. X is positive 15. Y is positive 30. And what is that equal to? Simple, straightforward. 45. 45 revs per minute. Again, this one is positive, so which means it is rotating clockwise. Yes. If it was negative, well, this is just a hypothetical. If it was negative for whatever reason, then you don't just slap anti-clockwise next to it. Right? You have to write it as 45 revs per minute. Then you state anti-clockwise. That's the right way of doing it. Am I clear here?
Yes, sir.
Right. When you do exercises that you were taught by me, you better do so like you have some sense. Remember, you are my products now. You're not just representing yourself, you are representing me. So do things the right way. Are we clear?
Yes, sir.
100%.
All right. Any questions? So that is the breakdown of how you solve problems in Epicyclic Gears. You apply these guidelines, no problem, based on Epicyclic Gears will be a problem. Very easy, straightforward. Just follow my guidelines and you'll be fine. Any questions? Hello, talking.
Ayavakala mfundisi.
So the question say if you can do an example where you're not given your ends, you need to look for the direction first before you can solve the problem.
I forget about those ones. You will never get that in the exam. So
Okay.
are you talking about questions where you have to calculate, say, the number of teeth?
Yes, first before you can start with the conditions.
Nah, don't worry about those questions.
Okay.
Those we can worry about next trimester, N5.
Okay.
All right. So right now, let's just keep it simple because it is simple.
Okay.
All right. But in N5, I'll take you through how you approach those questions.
Okay, so thank you.
All right. Any more questions? Right. No questions. I was hoping that doing this problem, doing this exercise wouldn't take this long, but it has. Unfortunately, I have to end the session here because of time. So, which means the question.
Sorry to cut you.
Yes.
Sorry to cut you, sir. Before you end the session, can you please give me clarity on a deep groove? I was hoping that we will do question 3. Yes, question 3 is not hard, but you'll think that you've crammed right, whereas not. Because I've seen once I've wrote on the test and what the memo looks like. And
Yeah.
my problem is with a deep groove roller bearing and a roller bearing. That one must be our P. Because according to my understanding and what I've learned, is that a deep groove roller is more or less like a ball. Our P must be 3. And the roller bearing at 10/3. The past problems that I did and my understanding, maybe I understood wrong, but for our test 2, what we hit in the memo, it's the other way around.
I will make this very easy for you. I will go to the notes that I sent you. Where's this thing? Bearings. Very simple to answer the question. There we go. Where's this thing? There we go. Right. Do you see the part where I write where P for roller bearings is 10/3 and for ball bearings 3?
Oh, so our question will always specify ball every time.
Yes. They'll either say roller bearings where the P you take is 10/3, or the question will be based on a ball bearing. They will tell you it's a ball bearing, in which case you will take P as 3. Right. If you look at the question 3, right, question 3, both questions based on this was a roller bearing.
Yeah. All right.
Yes. Hence we use 10/3.
Thanks.
So
All
either
right.
the type of bearing is a roller bearing or a ball bearing, and based on those types, you then use the appropriate P value. Right. Make sure you go through my notes, guys. Right. That's why I send them to you.
Okay.
Right. There was another question where I was surprised because the question I take you through on the video is much harder than the one that's in the test. Right. Next question.
The next question
Thank
is on it's on tension ratio. I know
attenuation.
we're not discussing that. Yes.
That's
So the phone, sorry.
That's belt drives.
Yes.
Okay,
So
okay.
I have
Wait.
two.
So I don't want to do belt drives right now because I haven't even sent you videos on belt drives. So first, let me send you videos on belt drives.
Mm-hmm. We don't have it on the exam.
It is in the exam. I'm saying I haven't sent you videos on belt drives. So first, let me
Okay.
send you videos on belt drives before
Mm-hmm.
you ask questions. Right. I will add more videos on belt drives. Belt drives is pretty straightforward as well. I also just take note that in the exam it's 5%. Right. But because it's very easy, I would advise that you do belt drives and attempt the question in the exam. It's easy, 5 marks. Right. But as far as
Okay.
questions, I want you guys to hold your questions right until after you've gone through the content I'm going to upload. Capish?
The second question was on the precision measurement.
Okay, precision measurement.
Um,
I said if you need help regarding precision measurement, you can either go recap on the videos that I've already uploaded, and then in doing so, if you still have questions, you can then ask me privately, because not everyone. I don't want to wait. I don't want to waste some of the
every time.
candidates' time here because most of you are fine with precision measurement, right?
Mm-hmm.
But I understand not all of you are fine. Hence, I'm saying recap on the videos and then touch me privately. I will definitely help you privately.
Okay.
Yes. Next.
Thank you, sir. Can you please send us the weighting for each section on the exam
I already
for
did.
mechanic?
It's in the syllabus. The
Okay,
syllabus I
boss.
said in the beginning of the trimester. Unless you look for it in the group and you don't find it. I don't know how though. But I did send the syllabus. It's in the syllabus. First, let's look at this quickly. I did share the syllabus with you. So it's one
It's
of the
still on the
first
group.
right. So make sure you go back to the syllabus. So this is the syllabus. Here's the mark allocation here. It is exactly like this. And if you look at the past papers I've given you, it is exactly like this. Right. So revisit the syllabus. Any more questions? Hello, talking to you.
All good.
All good. Right. The question on bearings we are going to do in the next section. In the next session, the next session, perhaps we can make it Monday. If we make it Monday, that will probably be the last session that we have, where we can discuss everything that you want us to discuss. But firstly, we'll discuss this question on bearings. Perhaps discuss metal cutting machines, belt drives, and then yeah, we'll be done by then. Because everything else, by everything else I mean gear drives, be it simple and compound gear systems or epicyclic gears, precision measurement, what else? Hydraulic systems. Those type of questions I will no longer answer during our live sessions, right? Because we have spent too much time on them. But I am willing to answer them if you have questions based on them privately. What I don't want to do is chow the little time that we have as far as live sessions. I don't know if I'm making sense here.
Yeah.
Yes, sir.
Several.
All right. So we can have a session on Monday, seeing that you are writing next week, Friday. So between Monday and Thursday, there'll be enough time for you to have had questions, have them answered during the live session, and do more practice to see if you understood based on the response I gave you during our live session. And by Friday, you should be good to go. So Monday, 6 p.m., be there or be square.
Thank you.